Okay, so we have series covered and we have parallel. Now parallel, since the voltage is all the same, if I can figure out what the voltage is, then I just figure all the currents because I have resistance, right? So I can figure all the currents and add them up, or I can just figure out all the resistors in parallel, make an equivalent circuit, and then I can figure out the current for that. When I go backwards, if all of them add up to that current, I'm okay. Okay, so I have to figure out each individual current, but it's easy because I have a resistor and a voltage, right? Make sense? Okay. So the one that's tricky is when we have series parallel. We have to identify which ones we can do first. Okay? So the one that I'm not going to do the one we get. I'm just going to just do 4 resistors. So let's do this. Oh, uh-oh. Somebody playing with my board. Just a minute, I gotta fix it. Let's see, how do I do that? You have to hold it here. Come on. Let's see. All right, well, let's do the whiteboard for now. I'll have to fix it. Somebody's fooling around with it.
There it goes.
Oh, there it goes. Let's see. It's too big. See if I can get it to go over there. I can see it here. It's too big. All right, we'll have to fix it later. Okay, so we're just going to work with 4 resistors at 10 volt. 1, R2, R3, and R4. All right, so we have to identify what we can do first, okay? So if we look at it, we go, it's kind of a mess.
Which one's negative, which one's positive?
And it really doesn't matter, but we will do that, okay? So we look at the resistor network and we go, well, what is it that I can do first? Well, there's only one thing that I can really do in this circuit first if I'm going to solve the resistor network. There's only 2 resistors that I can actually add together as a series circuit initially. So I identify that this circuit right here can be solved first, right? That's easy. So let's say it's 10 ohms, 10 ohms, 10 ohms, 10 ohms, okay? So I go, okay, well then that would be RT. RT equals what? This would be 4 there, so R4 plus R3, and that would be 10 plus 10. So RT equals 20. I can now draw an equivalent circuit. So I do that. I go, okay, so that means that this resistor here is still there. Well, and so is this resistor here is still there. But what happened to this one? It became a parallel resistor. Okay, and that's where people get confused. What happened to it once I made it into one resistor? Well, it's kind of, see how it's parallel there? Okay, so it actually ends up being RT right here. This is going to be what? R2, and this is going to be R1, right? Does that make sense?
Why wouldn't you do R1 and R4?
Okay, why wouldn't we do R1 and R4? Why wouldn't we do these two first? Right? But how are we going to do those two? They're in series, but then we have this resistor to deal with. Right? So how do we add them up? We can't just add all three of them up, can we? No. We can't add these two up. We got to consider this one. In fact, we got to consider these two if we try to add those two up. Okay?
Well, that's what I was curious. Why couldn't you do parallel on R2, R3, and then just make a...
Okay, so it's R2, R3. They really are in parallel, but so is that. See, so we got to consider that if we try to do these two in parallel. Okay? The only two that are in series and are not involved over here, they're just on the end there, in series, is those two. If I add those two together, I don't have to consider those right now. Okay? And it becomes that right there. Okay? So that's the trick, is to identify which resistors can I work with first. And I might even have 4 resistors here, 3 resistors here, whatever. I could add all of them up because they're right on that end loop right there, okay? So I can say, okay, for now I'll ignore this and I'll add all of those up and make one resistor out of them. Then I can stuff it right up there, okay? And now, when I look at that circuit, I go, okay, look. There's a set of parallel resistors right there that are on the end. So I can do something else, can't I? So that's what I'm going to do. I'm going to say, okay, RT1 equals, we're going to use RT and R2, okay? So R2 times RT over R2 plus RT, right? So that makes it 10 times 10 over 10 plus 10. That would be 100 divided by 20. And then what is that, 5? So now I've got 5 ohms, right? And I should put my ohms on here. I'm always ragging on you guys to do it, so I better do it. Okay, so I got my identifiers on. All right, now here's the trick.
But your RT's value was 20, I thought.
Here?
Yeah.
Oh, sorry. Yep. My mistake. Good catch. Okay, so you see what he said? R2 is 10, so it's 10 times 20 over 20 plus 10. Nice call, Mark. 200 divided by 30, and what does that come out to?
6.6 repeating.
Yeah, okay. I thought it was ohms. Okay. So, all right, so now we have to redraw the circuit again. This is why you do equivalent circuits. If you don't, you can't visualize it in your head and you make mistakes. So I redraw the circuit again and I go, oh, look at this. Now, RT1, that's 6.6 ohms. And what is that one? That's R1. And it's still 10 ohms, isn't it? Now my circuit's really simple. Now it's just RT2 equals R1 plus RT1. That means it's going to be 10 plus 6.6, which equals 16.6 ohms. So the total resistance, another equivalent circuit, RT2, is 16.6 ohms. Okay? And it's 10 volts. So now can I find the I of the circuit? Sure. Simple Ohm's law gives me I. Right? So I've now solved my circuit down. I have to identify where to start. So when I look at the circuit, I go, where do I start? Now, if I had had a resistor here and a resistor here, it still would work. It'd just be a little more complicated to solve, okay? But I could still do it. So you need to say, okay, which part of it can I actually do? Now, there's going to be circuits called mesh circuits where you actually have to do them all at once in upper math. Okay, so you use upper math to be able to solve the circuits. But in these cases, these are simple Ohm's law circuits. You don't have to use any upper math to do it. Okay, they work right out. All right, you guys okay with that one? Would you like to do another one? Are you okay? Good? Steve, you good? All right, so the lab was a simple circuit. It just had a couple more over here. So I had a resistor here and a resistor here. What do I do with that? Well, I solve this one, then I work my way back. Boom, 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 boom. It just had more solutions. You see that? Okay? And we're going to work on that lab today. You guys still have that lab on your breadboard, so we're going to work on that lab, okay? I would like to add a lead to it. Then we got to talk about voltage dividers a little later. So, and what I'll do is we'll get video here. I'll go ahead and shut it off, and I'll turn it back on. We're going to learn about pots today. You guys know about potentiometers? Okay, in your notes, this needs to go in your notes. Potentiometers, we call them pots, P-O-T. They are a variable resistor. Okay, I'm going to get this off the board. You guys got this in your notes?
Yep.
You good, Steve?
Yep.
Okay? Good. We're going to get this off the board and talk about pots. Wish my smart board worked, but it doesn't. So we'll just use the regular old board. All right. Regular resistor, fixed resistor, R1. It's whatever the resistance is in ohms, okay? A pot is variable. So it has a third connection. The resistor has a third connection. It's mechanical. I don't think we're going to get straight today. Okay? Oops, sorry. There you go. Don't have a knob for you, Steve.
On the homework it asked, it said, hey, how do you identify these? Well, usually it says back here, but
Yep.
this one doesn't say.
And if it doesn't, then you use an ohm meter.
Yeah.
And you figure out what it is, okay?
So
This one says on the front.
Yeah.
If you look right on the front. Most of the time it'll be stamped on them somewhere. But you will run into pots that don't have any stamps on them, okay? So you're going to have to just identify them with an ohm meter, okay?
What does that B stand for in front of the 100K?
Yeah, I don't know, and sometimes they put their own marks on it for their numbers. You know, it's probably a number in their catalog. They put a B in front of it, and it indicates something. The 100K, 100,000 ohm is what's important. Okay, so your pot is 100K ohms. That means if I look across this pin, and this pin, which are the outer pins. The outer pins, those are the pot, and that's the fixed part of the pot. When you look across there, that's the fixed resistance, okay? These two pins, this is what I see is this 100K right here, okay? Now, this is called the wiper. Put that in your notes because I guarantee it will show up on a test, and it's the most missed question in my class ever. Okay? Wiper.
Wiper, what do we say besides this wiper?
That's what you say. Because I'm going to ask you, what is the movable part in a pot called? The wiper. Okay? So, okay, so this moves up and down, and you can just turn your pot. I mean, you guys have all used these in stereos, I'm sure. I mean, I understand the new ones have a lot of buttons and they're digital, but the old ones didn't. If you got an old amplifier at home, you got a big old knob on it and you turn it. I always loved it. They started out with little tiny knobs. Then they realized that they were much more impressive if you put a gigantic knob on it. And it was just a little pot back there with a gigantic knob, but everybody loved them. And sometimes they'd put little dimples and they'd have a little ball bearing or whatever, so it'd go click, 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 click. So then it really felt cool, you know. So, and some of them were lit up, you know, so they looked really cool. But when you took them apart, that's all there was just a little pot behind there, you know, of a certain size. Okay. All right. So, how does this work? Well, it's got a little terminal here. It's got a little terminal here. It's got a little terminal here. So if I hook my circuit up to these two, if I move the pot all the way up to here, and I look across this terminal, what is my resistance?
You move it all the way up.
I moved it all the way up, right to here.
Where's the electricity coming from?
So my path is, and my current is this direction. Okay? Unknown circuit here.
So it would be your highest value?
So it would be my highest value. That is correct. What is the highest value?
100,000.
To 100,000 ohms, isn't it? So really, if I move it all the way up there, let's just move this up here. Okay, so it's up here to this dotted line. Really, it's across the resistor, which is the total resistance, 100,000 ohms. Okay? What if I move it all the way down to here? Now what? Well, if I don't have any resistance, it's like a short circuit. Okay? You have to be careful with pots if you're using leads and things like that, because if you hook it up, it'll work when it's at 100K. You move it down, and it passes by the resistance, say about 330 ohms, which is the minimum resistance without burning the lead out. Once you pass past that, it starts burning up the pot, and when you go to zero, it burns up the lead. So you have to be careful. You can actually go to zero or to 100,000, depending on where the wiper's at, okay? What would you do in that case? You have to have a fixed resistor in there to limit the current when the pot goes to zero. Okay? We're going to play around with that. The main thing is today is we're going to use it in what's called a Wheatstone's bridge, but we haven't got that far yet. So potentiometers are really not a mystery. They're just a mechanical device. And you'll find them in all sizes and shapes. They're fairly low current, these are. They're in the milliamps. So you can't put a motor on them, you'll just burn them up. There are rheostats. They usually have just 2 leads, and they're wire wound, and they can run motors. They're a little heavier This, let's see if I can steal this one over here, if it's over here. Here it is. This one here. This one's just a few ohms, probably about 10 ohms. And it's non-linear. This one's good for a lot of current and voltage. It's out of a big old welder. Okay? That one is actually a pot. It has 3 leads on it. So it can be used as a pot. We used to see a lot of them in theaters where they had to change the lights, they dimmed the lights. And some of them, I've got a couple at home that are massive, big pots, and they have a wheel on them, and you turn the wheel. They used them to dim the lights in the theaters.
Big ones?
Really big ones, yeah. And over the years, I've collected a couple of them because they're really, some of them are really ornate. They got really nice wheels on them, cast wheels and everything. And they could take a lot of current because those lights took a lot of current, you know. So, all right. Rheostats, like I say, they just have 2 leads usually, and they're used dim lights. Not so much anymore because now we can do it with electronics. So you don't see really big ones. Welders that came out of probably out of a welder of some type, gasoline welder of some type, had a generator and you could turn the current up and down. I have a really big trailer-mounted Lincoln welder, and it's got, you can change the transformer, or you can change the windings, not really transformer, you can change the windings, and you can set the current to the field by just turning it up and down. So when you're welding, if you need a certain current, you can just set it up or down, and boom, you got it, you know. So anyway, and pots are used everywhere, anywhere that you need a variable resistance. Now, there are what's called trim pots. Trim pots don't have a little snout sticking out. They have a spot where you can put a little screwdriver or a tool, and they go on a circuit board, and they're used where you don't have to set it very often. So you might have to just set the resistance, so you just tweak it until it's just right, and then you leave it. And sometimes they'll take and put a little dab of paint. Actually, fingernail polish works the greatest. A little red or whatever color, red's real popular. And you'll see technicians, they got fingernail polish in their kits. It's not to touch up their nails. It's to set those pots and then put a dab of fingernail polish on it, and it dries quickly and it keeps it in place. So depends on what you're doing. All kinds of equipment have little trim tabs in, okay? And some of them are pretty flimsy. You got to be really careful or you'll break them. So when you're tweaking on them, you got to be careful or you'll be replacing them. Okay? And they're usually written on them also, on the little trim tab that's usually written. Okay.
Siemens thermostats a lot.
Yes, you do. So, all right. So that's everything I can tell you about a pot, unless you have other questions. There's various lead configurations, but most of them just have a pin sticking out, and you weld a wire, you solder a wire to it. Okay. All right. Any other questions? These have a nut, so you can mount them in a panel. So. All right, let's turn this off for a minute, and then I can get some.